Hello and welcome to the OptiAssist for Simcenter3D tutorial 2 thickness molding optimization or plastic stool. As you see here, I have already loaded the model. The first thing we are going to do is run a simple analysis. From here, I'm going to right click and we're going to hit solve and click OK. Now I'll begin to run. Once that has run, you just need to click No and close all windows down. From here, we are going to open up the tree underneath the simulation navigator, open up results, double click on structural. Underneath structural, you can take a look at the displacement. Here you can see the load being produced onto the seat to simulate a person sitting or standing on the stool, which causes bowing at the base of it. And therefore this tutorial we're going to take a look at the optimization of the thicknesses of these ribs underneath to minimize the bowing. Once you're happy with that, we're going to click Return to Home. And go over to the OptiAssist ribbon and click on Thickness Optimization. This opens up the optimization window. And so the first thing we're going to do is on the subcase tab, we'll click on Standing Load as our subcase, as our load case. Click Next. Here we come to the Design Rule tab, to which we will create a new rule. For the minimum thickness of this, we are going to select 2.5 and the maximum will be 8 mm. So click OK. And from here we are going to assign the rule to the plastic stool component. So add rule here. We are now going to repeat the process. So again, a new rule, however under type it will be subdivision, which will be assigning different thicknesses to each different rib. Underneath the patch creation method, we're going to change it to feature angle, with the angle being 30 degrees. Click Generate. Once the patches have been made, all you need to do now is just deselect the load container, and we can see that the patch has been missed out. To combine the patch 1 and 3, deselect load, now need to finish the patches, so just going to click Feature Angular Element and click the missing pieces. From there, we'll update patch and click on patch 3 as it entirely covered. You click OK, and again add the design rule. Once you're happy with that, we're going to click Next. The goal is to minimize the mess, and we'll do it for the entire model, so that is absolutely fine. From here, we'll click Next again. We come to the Constraint tab, where we will add a new constraint. We want the response type for this constraint to be displacement, whereby the upper limit is 5.5. We can leave the lower limit blank. For the direction node, we will put in the node ID of 11935 and click OK. Just click the load case and then click OK. From here we will click Next, and under the Settings tab we will change the max design cycles to 20. Click OK. And under the OptiAssist tab and under the OptiAssist ribbon, we now just need to click Solve. Once this is ran, you just need to click No and close all the windows. And the first thing we're going to take a look at is the design history. Just going to click plot. So you can see it initially rose up to 3.8 as the thickness increased, before being reduced through optimization to 2.6. I'm just going to click close. And then we're going to have a look at the results. So here under OptiAssist solution, we're going to take a look at the results, double click structural, and then take a look at the OptiAssist solution latest cycle, displacement, magnitude. And now you can see the maximum displacement has now decreased. Once you're happy taking a look at the results, you're going to click return to home, OptiAssist ribbon, and then thickness contour. Load results, latest cycle, and plot. And under here we can see an increased thickness, with the middle of the ribs increased up to 8 mm, and the blues staying at around 2.5. Once you're happy with that, we are now just going to update the model results. Just click on Update Model Problem Results, latest cycle, and OK. Yes. This has now increased the thickness of the ribs through optimization, which concludes the tutorial.